Imagine waking up, looking at our familiar blue marble from space, and realizing something is fundamentally wrong. The continents, the forests, the deserts, all of it just totally gone. Take a look at this concept. What if Earth lost all its land? No North America, no Africa, definitely no towering Himalayas or sprawling cities glowing in the night. It's just an endless, shimmering ocean. We're dropping right into a high-stakes thought experiment today. Think about it. If you dropped a stone anywhere on this planet, it would literally fall for thousands of feet into absolute darkness without ever hitting a rock you could stand on.
Creating a global ocean. Okay, so how do we even get a water world in the first place? Scientifically speaking, we basically have two fascinating options here. Scenario 1 doesn't actually require adding a single drop of new water to the planet. We just take a giant cosmic iron and flatten the bumpy crust. You smooth out Mount Everest, fill in the Mariana Trench, and just keep going until the Earth is as smooth as a cue ball. Scenario 2, we keep our continents exactly as they are, but we bombard the Earth with millions of icy space comets early in its history, delivering enough extra water to completely drown the top of the Himalayas.
Now, if we focus on that first scenario and just flatten the crust, the existing water in our oceans redistributes to cover the entire globe uniformly, and it would sit at a depth of roughly 1.7 miles. Try to picture that. That is deeper than 6 Empire State Buildings stacked right on top of each other. No mountains, no islands, no sandbars. Just 1.7 miles of endless blue in every single direction.
Monster weather and endless tides.
Here on our actual Earth, giant mountain ranges like the Rockies and the Alps act like massive atmospheric speed bumps. They break up winds and redirect storms. But without them, there is absolutely no continental drag to slow things down. The atmosphere settles into these incredibly stable, super powerful wind belts. We're talking everyday baseline winds at the surface howling continuously at over 100 miles per hour. That isn't just a temporary storm passing through. On a water world, a 100-mile-per-hour wind is just your normal Tuesday.
And this lack of land fundamentally changes how storms behave too. You see, on our Earth, a hurricane dies out when it hits a continent because it loses its warm moisture supply. But here, storms just keep feeding on that infinite ocean vapor. They evolve into relentless, roaming hypercanes. We are talking about monster storms the size of entire continents, packing winds well over 200 miles per hour that could last for months, maybe even years, just continuously roving across that massive blue expanse.
And if you think the wind sounds terrifying, just wait until you see the water. Add the moon's gravity into the mix, but without any coastlines to break up the tidal energy, and the entire ocean basically becomes a single, fluid, ringing bell. You don't get gentle beach waves here. You get continuous, rolling tidal swell waves that are hundreds of miles long and dozens of feet high, constantly traveling around the planet in a never-ending loop.
The biological desert paradox.
Now, you'd probably think an endless ocean would be an absolute paradise for marine life, right? Like just global pods of whales and giant squids ruling the world. But nature has a massive paradox waiting for us. The crucial point here is that the entire marine food chain relies heavily on land-based nutrients. Things like phytoplankton need iron and phosphorus to survive. On Earth, rain hits rocks, dissolves those minerals, and washes them into rivers, which then dump them into the sea. Even dust storms blow essential nutrients from the Sahara directly into the ocean. But on an aquaplanet, this entire pipeline is totally missing. There is zero land runoff.
And without that crucial runoff, when marine organisms die, their bodies and all the precious iron and phosphorus inside them just sink miles down to the dark abyss. Because the ocean is so incredibly deep, those nutrients get permanently trapped way, way below the sunlight zone. The sunlit surface would very quickly run out of minerals, leaving the upper layers of the ocean sparkling, crystal clear, and almost completely lifeless.
Life wouldn't be completely extinguished, but it would only survive in tiny, isolated oases. Deep at the bottom, Earth's internal volcanic heat would still forge hydrothermal vents. Down there, completely cut off from the sun, you'd find bizarre ecosystems of giant tube worms and blind shrimp. They'd thrive on something called chemosynthesis, converting the scalding chemical energy bubbling up from the planet's mantle directly into food.
Exotic ice at extreme depths.
Let's switch gears and go back to our second scenario for a moment. Remember the one where comets bombard the Earth and make the ocean 60 miles deep? Well, the physics of a 60-mile deep ocean are completely mind-blowing. Down at those extreme depths,
The sheer weight of the water creates a crushing force 20,000 times greater than atmospheric pressure at sea level. Under this immense pressure, water molecules are squished together so incredibly tight that they actually freeze into a glowing, hot, solid crystal known as Ice-VII. That's right, even if the water is physically warm, the sheer pressure forces it to become a solid.
And because Ice-VII is incredibly dense and heavy, it sinks. This means at the bottom of our super deep ocean, you wouldn't even find a rocky seafloor. You would find a layer of hot ice, hundreds of miles thick. It acts like an impenetrable blanket over the planet's core, stopping all those volcanic nutrients and hydrothermal vents from ever reaching the water. Ironically, adding way more water just creates a completely frozen off, dead world.
The human survival problem.
So, what if you and I were suddenly dropped into this water world today? How would human civilization actually fare against the endless blue? Well, we could technically survive, but it would be absolutely grueling. We'd have to become nomadic seafarers, living on floating modular raft cities made from lightweight composites. And our biggest threat, it would ironically be thirst. We'd be desperately relying on solar-powered desalination stills just to turn seawater into drinking water so we wouldn't die of dehydration. Our diets would be mostly marine birds, fish, and farmed underwater kelp, all while we try to harness those relentless 100-mile-per-hour winds to generate energy.
But here is the massive fire paradox that stops absolutely everything in its tracks. Think about it. Every single step of human technological progress, smelting iron, making glass, refining silicone for microchips, it all requires high-temperature fire. Without dry land, you have no coal, no iron ore, and no dry wood to burn. You simply cannot light a forge on a wooden raft in the middle of a 100-mile-per-hour windstorm. This means any society on a waterworld would be permanently trapped in a technological stone age.
Real waterworlds in space.
Now, I know everything we've talked about so far sounds like pure science fiction, or maybe some apocalyptic movie plot. But as we zoom out into the cosmos, we find that this thought experiment is actually a very real cosmic reality. When NASA's Kepler and James Webb Space Telescopes looked out into our galaxy, they found hundreds of planets called super-Earths and mini-Neptunes. Density measurements reveal that planets like GJ1214b are likely composed of deep, deep water wrapped in thick steam atmospheres. These actual deep water planets might actually be far more common in our galaxy than rocky planets like Earth. Millions of real-life water worlds are sitting right out there in the dark.
The value of dry dirt.
So, after diving through all these incredible scenarios, why does all of this matter? What should you actually take away from this explainer? Well, this whole thought experiment teaches us a pretty profound lesson about our home. We love calling Earth the blue planet, but our dry dirt is the essential engine for everything we know. Land drives our climate stability, it provides the crucial minerals that allow ocean life to bloom, it gave us caves to hide in, wood to burn, metal to forge, and a stable, solid platform to build our modern world.
Without land, humanity simply wouldn't exist to look up at the stars and ask, what if? So, the next time you take a walk in a forest, or just feel the dirt under your shoes, maybe give a little thanks for solid ground. And I'll leave you with this final thought. What would you do, and how would you actually survive if you woke up tomorrow on a true water world?
Please like and subscribe.